Hello everyone, welcome to the 7th tutorial session of Probability Foundation for Electrical Engineers. Our instructor is Professor Krishna Jagannathan sir from IIT Madras, and I am Satyakam Pratap Singh, a PMRF Research Scholar at Department of Energy Science Engineering, IIT Bombay. So we have already seen few of the tutorial session, which will help to you to solve the assignment 4, 5, 6 and all. So, and also a few problems related to probability, some statistics and all problems are there. We have already seen. So we are moving forward and putting some of the problems in continuation with the last tutorial session. Okay, that will help you to solve the other tutorials, other assignments. Okay, this is the first problem. Before you try to solve this, and let me know if you face any problem in this. Okay, let me give the solution for this. When you see that it is asking that you are having a probability space whose events are A and B, and probability of occurrence of A and B are equal, that is 0.25 and 0.25, and probability of A union B is given zero point 0.3. Okay, it is asking to compute this. Okay, When you see that when you compute this integral of b 1a of dp, that is simply equal to integral of 1a 1b dp, that is similar to the probability of occurrence of a intersection b, and we already know that probability of a union b is equal to probability of a probability of b minus of probability of a intersection b. Okay, so how to find probability of a intersection b? That is simply equal to probability of a plus probability of b minus of probability of a union b. Okay, what is probability of a? It is given here. It's a 0.25 and 0.25 minus probability of a union b. A union b, it is already given zero point 0.3. Okay, this is zero point 0.5 minus zero point 0.3, that is equal to zero point 0.2. Okay, that is the correct answer. So correct answer is option B. Okay, any doubt? When you see that probability space in the b terms, that is 1a dp, that is simply equal to 1a 1b dp, that is simply probability of a intersection b. Probability of a union b is probability of a, probability of b minus probability of a intersection b. So probability of a intersection b will be probability of a, probability of b minus probability of a union b. Probability of A is given 0.25, probability of B is given 0.25, and probability of A union B is zero point 0.3. So when you find it out, it is 0.25 plus 0.25 minus zero point 0.3 and is simply equal to zero point 0.5 minus zero point 0.3, that is zero point 0.2. Okay. Let's move forward, try to solve this problem. Here it is given x is a binomial distribution in n and p, where you have to find out the expectation of x. Okay, let me give the solution for this. So it is asking that x is a binomial distribution NNP. The expectation of x is equal to. When you see that what is the expectation of x, this is simply because it's in the discrete format. It is asking. So when you decompose it, okay. So expectation is simply that is p will come. That is that x is summation of I from 1 to n. That is I summation. I is simply equal to Bernoulli's of P. Okay. Okay. So when you solve it, the expectation will come out to be P. Okay. Expectation of indicator EIP. But what it is asking, it's expectation of X. Okay. That is simply the linear value. So when you y is equal to 1 to n, expectation of I. When you put the value, it will simply I is equal to 1 to n p is equal to p plus dot 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 till n term, that is equal to n term, that is equal to n times of p. So correct answer will come out to be option A. Okay. Let's move forward. Try to solve this. It is asking what is the second moment, that is expectation of x square. First moment is simply expectation of x. Second moment expectation of x square. It is being asked. Try to solve and let me know if you face any problem. Okay, let me give the solution for this. It is being asked that x is the binomial distribution n and p. The second moment is being asked that is expectation of x square. When you see that x is simply when you decompose it, I is equal to 1 to n I. So I is equal to Bernoulli's of p. So when you find out the mean is expectation of x that we have already pointed out, that is np. When you solve for this variance of x, that is equal to variance of I, that is np 1 minus p. So expectation of x square is equal to variance of x plus expectation of x of whole square. Okay. Or okay. So when you solve it, variance is np 1 minus p plus np of whole square. When you solve np minus n times of p square plus n square p square, solve it, you will get n square p square plus np, take it common. Np, when you take it common, it is 1 minus p. Okay. So this simply is equal to n square p square, n square p square, np 1 minus p. Option B is correct. Okay. Let's move forward. Try to solve this problem. That is simpler problem. You have to just put the values and solve for it. Okay, let me give the solution for this. The question is said that it is asking x is a binomial distribution in NP. Here n is given as a 12 and p is given as zero point 0.5. It is being asked what is the expectation of x square. Okay, so we have already solved that expectation of x is equal to simply NP, and variance of x is equal to NP 1 minus p. Okay, so expectation x, it will be simply equal to what is n? N is equal to 12 and p is equal to half. Okay, just multiply it. Multiply it means 12 multiplied by 1 by 2, we will get 6. And what is the variance of x? Variance of x will be equal to np, and p 1 minus p. 1 minus p is 1 minus half, that is half only. So it will come out to be 3. So what is the value of expectation of x square? It is simply equal to expectation of, or you can say that expectation of x of whole of square plus variance of x, that is simply equal to 6 of square plus 3, that is 36 plus 3 equal to 39. Okay, so simply you have to just remember that what is the expectation of x and variance of x, that is np and np1 minus p. Just put the value here. N is already given 12, p is 1 by 2, so it simply np will become 6, and variance of x is np1 minus p, that is 12 multiplied by half multiplied by half, that is 3. So expectation of x square is variance of x plus expectation of x of whole square. So variance of x we have already calculated, that is 3. Expectation of x of whole square, that is 6 of square, that is 36 plus 3 is 39. Okay, correct answer is option B. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. It is saying that xy is in the uniform distribution of 0 to 1. That is simply 0 to 1. It is a uniform distribution. And then it is saying that u is equal to x and v is equal to x plus y. It is asking what is the support of uv. Okay, when you see that, uh, because when you see that u is already equal to x, here it is saying, and x is in the uniform distribution of 0 to 1. Okay, so u is simply equal to in between 0 to 1. That is simply will come out to be. Okay, and v is equal to x plus y, and if you see that x is equal to u plus y is also belonging to the 0 to 1. So simply you can say that v is belonging to u and u plus 1. Okay, so when you see that u plus v is belonging to in between u plus 1, and u is belonging to 0 to 1. Okay, so v will simply in between the, uh, you can say that v is in will belong to u comma u plus 1. Okay, and u belongs to 0 to 1. That is because of the uniform distribution. Okay, so u is equal to simply x, and x is in the uniform distribution, that is 0 to 1. So simply u will be in between 0 to 1, and v will be in between u and u plus 1, because v is the x plus y, and x and y both are in the uniform distribution. So option A is actually correct. Okay, let's move forward, try to solve this. You have to find out the what is the joint density in f of uv when you're having the u and v. Okay, let me explain this problem. It is saying that xy in the uniform distribution of 0 to 1, and u is already given x and v is x plus y. So it is asking what is the joint density function of fu and in between u and v. Okay. To solve this problem, you already know if it is a uniform distribution, so u will be equal to 1 because simply when you see that u belonging to in between 0 to 1. Okay, and u is equal to x because u is equal to x and v is equal to x plus y. Okay, and x and y belongs to 0 to 1, that is in the uniform distribution. So v will be equal to belonging to u comma u plus 1. Okay, so you can simply also say that y. What about the y? Y is also in between 0 to 1. Y is simply equal to v minus x. V minus x means v minus u is simply in between 0 to 1. Okay. So when you try to solve this, fxy is simply equal to 1. X is in between 0 to 1. Y is equal to 0 to 1. Okay. U is equal to x. V is equal to x plus y. X is u and y is equal to v minus u. Okay. Getting my point? Okay, find the Jacobian del of xy uv. When you solve it, you will get 1 0 minus 1 1. If you find out a determinant, it will simply equal to 1. Okay, so x is in between 0 to 1, y is in between 0 to 1. So simply u is equal to 0 to 1 and v minus u is equal to 0 to 1. Okay, when you solve it, it will simply equal to fxy u v minus u dot 1 is equal to 1 because u is in between the 0 to 1 and v minus v is also is in between 0 to 1. Okay, so what is the correct answer? Option will be option A because uv is simply in between 0 to 1 and v minus vu is also uniform distribution, that's why it is in between 0 to 1. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. What it is saying, you can say that ki it is saying that xy is in the uniform distribution of 0 to 1, and s is defined as x plus y. Okay, it is being asked what is the pdf of s will be, means probability density function of s. It is being asked. When you see that fss, what is given, fss, when you see s is equal to x plus y, simply that's fine. So when you see that x and y is belonging to uniform distribution of 0 to 1, simply, so s is belonging to in between 0 to 2, basically. So this is like this: 0 to 1, it is simply x, and this is y in between 0 to 1. So s is will be simply equal to, increasing in the magnitude y, that is 0 to 1, that is 2. Okay, so s is simply x plus y. S is belonging to 0 to 2. Okay, so s fss is s in between 0 to 1, 1 to 2 in between 2 minus s, and 0 otherwise. Okay, s is equal to x plus y, xy belonging to 0 1, so s belongs to 0 to 2. Fx fy is equal to 1 in between 0 to 1, so fss s is equal to, when you integrate, minus infinity to infinity, fsx fy s minus x, okay, dx. It will simply equal to 0 to 1 dx. And overlapping length, when you see, so x is belonging into 0 to 1, that is simply from the definition itself, and intersection between the s minus 1 and s. Okay, when you solve it, if s is belonging to 0 to 1, this often it is simply equal to s, so interval will be simply equal to 0 to s. And when it in between the 1 to 2, uh, in a closed, in a open interval of 1, so it is simply equal to s minus 1 1. Okay, length is actually s minus 1 minus 1, that is simply equal to s minus 2. Okay, so when you combine both, so it gives a triangular function. Okay, when you see that, it is simply equal to, when you having s is in between 0 to 1, simply yes. When you in between the 0 to 2, 1 to 2, it is simply equal to 2 minus s. So at 1 it will be 1, but when you see 2 minus s, this is simply equal to, when you put the value of s, it is equal to 1, and it will drop down. So what is y is equal to mx plus c kind of curve, simply equal to triangular function. So how it is matching, it is matching with the option, when you see option a. Okay, that is simply, when you see that ks is in between 0 to 1, and 2 minus s, that is in between 1 to 2, that is simply s, and this is 2 minus s, that is kind of triangular function. Okay, let's move forward. Try to solve this problem. In this problem, it is simply being asking that ki, if you are having the u equal to x, and x and y is in the uniform distribution, so, and v is equal to x plus y, it is asking whether u and v are independent or dependent. Yes, no, or there is a possibility that when you equalize both, that is u is equal to x, then only the u and y will be the independent. Okay, try to solve this. Okay, let me give the solution. What it is saying that x and y is the uniform distribution in 0 to 1, and it is defined u is equal to x and v is equal to x plus y, and simply it is asking whether u and v are independent or dependent. Okay, and if it is not dependent, whatever will be the condition to make it u and v are dependent. Okay, when you see that x is belonging to 0 to 1, okay, and v is equal to x plus y, so v will be belonging to, if u is equal to x and x and y belonging to, so x is belonging to the 0 to 1, simply v is equal to x plus y, so it will be belonging to in between 0 to 1. Okay, okay, so u will be in between 0 to 1 simply, and v minus u will be 0 to 1, because simply when you see the y is equal to v minus x is u, so v minus u. Okay, when you see the joint pdf means when you wanted to find fuv, okay, is equal to 1, because u is equal to in between 0 to 1 and v minus u is equal to 0 to 1. Okay, in this condition only. Okay, otherwise it will be 0, because it's a uniform distribution and it's lying in between 0 to 1. Okay, so what will be the marginals? Marginals will be FUV is equal to 1 on 0 to 1, or FVU, you can say that V in between 0 to 1 is V, and V in between 1 to 2 is 2 minus V. Okay, so it's a non-factorable. Okay, and so it is dependent upon the U only. Let's take one example. Suppose U is equal to zero point 0.2 and V is equal to zero point 0.1. When you see that, what is will be the value of FUU? Okay, dot FVV equal to 1 dot zero point 0.1, because FUU is already 1 in the all the cases, but what is what the zero point 0.1, it is simply if it is in 0 to 1, so it will be simply V, so it will come out with 0.1, and it is greater than 0. Okay, so but otherwise when you see that FUV V minus U is equal to 0, when V is equal to less than V is less than V. Okay, so it means that FUVs does not equal to FU dot FV, so they are not independent. Okay, so they are basically dependent. So you can check also with the covariance. If the covariance of U and V is simply equal to variance of X, that is 1 by 12, and it is not equal to 0, so it is not independent. Okay, so simply the correct answer will be option B. So they are not independent. Let's move forward. So here in this problem it is saying x1 x2 x3, there are n number of x are there, and they all are in the uniform distribution 0 to 1. So we are fixing a constant, that is c, which is belonging to 0 to 1. So define the stopping time, that is n is equal to minimum of n such that xn is greater than c. So it is asking what is the distribution of n is. Okay, try to solve this. So in this, stopping time will be simply equal to n is equal to minimum of n such that xn is greater than c. Okay, so the minimum value you have to say that this is the stopping time. Okay, so you have to say that what is the distribution of n will be, whether it is a Poisson, whether it is geometric series or binomial or negative binomial with some value of r is equal to 2 basically. Try to solve. Okay, let me give the solution for this. So what is saying that ki if you are fixing the c belonging to 0 to 1, so define the stopping time, that is asking that what is the distribution of n. When you see the probability of x is greater than c, that is simply equal to 1 minus c, because this is geometric. Okay, because x is in uniform distribution in between 0 to 1, so that is 1 minus c is simply equal to p. So when you see stopping time, n is equal to minimum of n such that xn is greater than c. So is the number of ID trial until the first success, that is xn is greater than c. So when you wanted to find out what is the PMF, PMF is equal to simply probability of n is equal to n, or you can say that x1 is probability of x1 is less than or equal to c, or you can say the x2 is less than or equal to c, or dot 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 xn minus 1 is less than or equal to c, or and xn is greater than c. Okay, that is simply equal to c to the power n minus 1, because these are the all the equal terms c, and this is 1 minus c. Okay, here c is 1 minus c is simply p, so when you can replace that, c is 1 minus p, 1 minus p to the power n minus 1, and it's simply p, and n is greater or equal to 1. So this is the correct answer. When you see that key, this is when you find out the what is the expectation of n, expectation of n of this value, that is simply 1 minus 1, 1 upon 1 minus c, and this variance of n is equal to c divided by 1 minus c of whole square. That is actually matching with the b. Okay, let's move forward, try to solve this problem. In this, you have to simply find out what is the value of expectation of n. Okay, let me give the solution for this. When you see the problem, it is saying that n is equal to minimum of n such that xn is greater than c for fixed c is belonging to 0 to 1. What is the expectation of n? So when you see that x is in the uniform distribution of 0 to 1 and what is asking probability of x greater than c, that is simply equal to 1 minus c or equal to p. Okay, n is minimum of n such that xn is greater than c, so simply it's a geometric series of p on 1 to n. So we have already seen that is simply expectation of n will be 1 upon p is 1 minus c, so it will be equal to 1 upon 1 minus c. That is simply option b. Let's move forward, try to solve this problem. Okay, let me explain this. It is saying x1, x2 is a uniform distribution 0 to 1, and what is asking that distribution of xn. When you see that n is minimum of n, such that xn is greater than c, so the key idea is that given n is equal to small n, we know that all the xn is actually less than c, and xn itself, last term, is greater than c. So when you see that key, see, since the every n is in between n to n, and it is a uniform distribution in between c to 1. Okay. So unconditional xn is actually a mixture of over all the n. Okay. So simply it is saying that uniform in between c to 1. When you try to quick check that, so x is in between c to 1, so probability of action is less than or equal to n is equal to probability of n is equal to n, action is less than or equal to x. So action is less than or equal to c, action is less than n minus c, and simply last time when you see the action one is in between less than or equal to x and greater than c. So when you sum up, so it says simply c to the power n minus 1 x minus c. So this is x minus c, and when you sum it up, it is x minus c divided by 1 minus c. So that is expectation. When you see the CDF, when you're having the CDF in between 0 to 1, there you got 1 upon 1 minus c. Here the CDF is uniform in between c to 1. So the answer is x minus c divided by 1 minus c. So it's a uniform distribution in between c comma 1. Try to solve this problem. Okay, let me give the solution for this. When you see that it is asking what is the values of x1 x2 informed distribution, simply whether x and xn are independent or dependent. Okay, so that is simply a function that when you tried to solve the in the previous problem that c in between the c to 1, x in between c to 1, so probability of xn when it is less than or equal to x such that n is equal to n is already occurred, so it is simply equal to x minus c divided by 1 minus c. When you divide that try to find out the joint cdf piecewise, that is x is equal to c to 1, uh, c to 1. So p is equal to n to n, xn is less than or equal to n. So probability of n is equal to n and probability of xn is less than or equal to n such that n is equal to 1. So it is simply equal to 1 minus c 1 minus c to the power n minus 1 dot x minus c divided by 1 minus c. So when you multiply it, 1 minus c will get cancelled out, c is c power n minus 1 and x minus c. So when you factorize it, when you factorize this, simply equal to x minus c divided by 1 minus c, and that is xn is in the uniform distribution c to 1. So when you try to solve the probability of n is equal to n and such that xn is less equal to x, so it is simply equal to probability of n is equal to n, probability of xn less equal to x. This is for the all n, okay, and for the x which is belonging to c to 1, okay. So when you see the both the value, it is coming equal. So whether when you're taking the xn less than equal to x and the same time n is equal to n also, so that is being equal to when you take it the separately, probability of n is equal to n and probability of xn less than equal to x. So if both terms are equal, so they are considered as independent. So correct answer will be the in the question it is asking n and xn are independent. So yes, it is independent. Okay. Try to solve this problem. Next problem. Okay, let me give the solution for this. When you see that x and y is an exponential distribution 1 and define in that t is equal to minimum of x and y and I is equal to 1 such that x is less than y, it is asking which option is actually correct. So by the distribution of the minimum, when you go, that is p is t greater than t, small t. So p will be x greater than t and y is greater than 2. So it is simply equal to exponential of 1. So it is e to the power minus t dot e to the power minus t is equal to e to the power minus 2t. Simply equal to t is greater than equal to 2. Okay. When you differentiate ft t is equal to t, that is equal to d by dt is 1 minus e to the power minus 2t is equal to 2 e to the power minus 2t. That is simply equal to t is exponential of 2. By symmetry, p I is equal to 1 equal to probability of x less than y is equal to half. So by the independence, that is for t is greater equal to 0. So probability of t comma t I, that is t comma 1 is simply equal to a function of x y, x is equal to t comma y dy. So when you put the value, that is integral from t is equal to infinity t to infinity e to the power minus t e to the power minus y. When you solve it, so t to infinity e to the power minus y simply equal to e to the power minus t. So multiply it, it will come out to be e to the power minus 2t. Okay, or you can say that 2 e to the power minus 2t dot half. Okay, t and I are factorizable, so they are independent. Okay, so the correct option when you see that, it's option B. So t is nearly equal to exponential of 2 and t is independent of I. Okay, let's move forward, try to solve the last problem of the today's tutorial session. Okay, let me give the solution for this. So it is saying that ki u is equal to x plus y and w is equal to x minus y for real x comma y. The inverse of x is equal to u plus y by 2 and y is equal to u minus w by 2. So it is asking what is Jacobian of determinant of this del of xy and del uv. So that is simply equal to del of x comma y del of, let me see, uw simply equal to del x by del u del x by del w del y by del u del y by del w. When you solve it, it will come out to be half, 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 minus half. Try to find out determinant. That is equal to 1 minus 1 by 4 minus 1 by 4. Take the mod, it will simply equal to 1 by 2, that is 0.5. Okay, that is the correct answer. So it will be option B. Okay, that's all for the tutorial session. So we have seen a few of the problems. If you face any doubt, just let me know in the next tutorial session. Okay, thank you so much.